Now, the last session, that is session 15, that is on advanced materials. This session is handling by Dr. S Mohan Kumar sir. So they have done BA Mechanical, M.Tech and PhD. After they are former principal at Government Engineering College Hassan and SDMCET Dharwad, and also they are ex-professor in Mechanical Engineering, Malnad College of Engineering, Hassan. Their awards, Government of India's DST, Ministry of S&T, Boys Cast Young Scientist during 1990-91 in the area of robotics and automation, and was a visiting research faculty at University of Minnesota, USA. GOK, Government of Karnataka's Sir C.V. Raman Young Scientist in the year 1997 in recognition of outstanding contribution to engineering science, and their academic achievements: total teaching experience of 38 years, experience as a professor 21 years, number of research publication is 150, number of PhD produced is 5, number of PhDs guiding at present 9, number of patentable products 10, served as BOS and BOE member for Mysore and Colombo universities and VTU, number of books published is 5, responsible for implementing computer-aided engineering drawing in the BE curricula, first of its kind in the country, conducted as many as 10 national level workshops for quality enhancement of teaching and learning processes and bridging gap between industry and academia, certified international trainer for VTU, Bosch, Rexort, International Center for Competence in Industrial Automation, technical expert for urban revival programs for major cities like Hassan, Bangalore, and the towns of Hassan district, initiated state-of-the-art interdisciplinary M.Tech course in Industrial Automation and Robotics at MCE, Hassan, first ever in the country, taught more than 20 UG/PG courses and guided about 150 UG/PG projects, one of the senior most expert committee member for AICTE NBA, presently serving an editor for the International Journal of Robotics and Mechanical Engineering Research for Arizona Publishers, UK, served as a governing and academic councillor member for various colleges in the state and delivered as many as 55 invited lectures in the area of automation, robotics, CAD and CAM, digital and collaborative manufacturing, and conducted an unique attitude transformation workshop on bringing industry to institutions to beat global meltdown in February 2009. And finally believes in OBE and meaningful contributions present in MHRD's AIB, PGERET, All India PG Board, ACT Stanford Advisory and NEET platform for student learning, assessment and skilled empowerment in a quest to strengthen the employability of technical graduates of all engineering institutions coming under the ambit of AICTE. And the recent participations as a lead by Professor S. Mohan Kumar is conducted and organized and coordinated as many as 74 workshops, seminar, FTPs during May 2011, August 2014 at SDMCET Dharwad, while working as a principal director as well as the principal investigating authority for TechWeek Phase 2 activities. The last program being the workshop on good governance and leadership development in technical education on 18th June 2014 for BOG members and senior faculty members of TechWeek institutions in collaboration with Board of IT Education Standards, Bangalore. Chaired the panel discussion in the afternoon session on role of robotic science in STEM education, dated 19th October 2016 during the 3rd International Symposium STEM Fest 2016 held during 17th to 20 at University of Mysore Senate Hall. Chaired session in the noon session dated 5/3/2017, delivered invited lectures on digital and collaborative manufacturing as chief guest in inaugural and valedictory sessions for the one-week training program at the Department of IP&E, Malnad College of Engineering, Hassan, for PG and research scholars of Jorhat Government Engineering College held during 6th-11th July 2018. Chief guest in inaugural and valedictory sessions for 1 week online FDP online learning and assessment system 18th to 22nd June 2020, organized by Institution of Engineers, Kalburgi Local Center, Karnataka. Chief guest in inaugural session of 3 days CCTP and smart manufacturing held during 3rd to 5th July 2020, organized by Department of Science and Technology, Government of Bihar and Government Engineering College of Jamui Mungar Lakirshi. Lead speaker for the motivation speech and career guidance program for the after 12th standard students of Karnataka State in the one-day panel discussion workshop organized by Bhimana Kanda Institute of Technology, Balki, on Sunday, 16 August 2020. And recent engagements rigorously involved since the first week of March 2020, the onset of national lockdowns due to COVID-19, and worked towards mitigation of COVID-19 and eradication of coronavirus in order to save humanity, and same came out with a novel and workable perennial solution of safe, simple, and smart lockdown TSLS strategy, with works on ISCM on Digital India platform and rigorously utilizes Ayur Yoga practices, the heritage of India. Delivered keynote lecture on online learning assessment system as a chief guest in inaugural and valedictory sessions for 1 week online FDP 18 to 22 June 2020, organized by Institute of Engineers, Kalburgi local. Delivered lecture on smart manufacturing as chief guest in inaugural session for 3 days TP held during 3 to 5 July 2020. And also communicated about 10 papers recently to peer reviewed Scopus Index journals. So we are proud to have the esteemed resource person here. So thank you, sir. Thank you for joining with us for a second session for our robotics. So thank you very much for here. And over to you, sir. You can now proceed with your presentation, sir. Thank you.
Thank you, Dhruv Kumar. And good afternoon, all the participants. Are you hearing me? So,
Yes, sir, we can able to hear.
Yes. So now, actually, on the first day of the inauguration, I was to talk about, the robotics introduction. But what happened? Because of the internet problems, you must be knowing, I went hurriedly and almost covered, 3 to 4 hours of lecture. I don't know. It must have been very, very difficult for you because it was a marathon from my side. So anyway, excuse me for that. Today we are going to have a leisurely session on the future and advancements in robotics. But some of the slides which have been put on the advancements and the videos I will be playing again, dear participants. So it's a real honor. I think you must have had lot of, the program and lecture series on robotics. You had basics of robotics constructions. You had future emerging challenges, application of sensors, then autonomous navigation, robot kinematics, then 3D transformations, homogeneous transformations, robot intelligence. I think it's too much. But even then, I just want to make it, all of them, very simple through the livid examples of the videos, which I'll be presenting to you. And today, you must be knowing, there was a session in the morning, industrial automation and robotics. Actually, industrial automation and robotics is my hot area, wherein, I strived hard more than 3 decades, to tell you very frankly, because I was in University of Minnesota in the area of automation department, Industrial Productivity Center of University of Minnesota, USA, and I was a Government of India Boyscast awardee, and it was a real scintillating experience. After coming back, I started one of a unique interdisciplinary MTech course in the country. That is first time in the country. That was at Malnad Engineering College, Hassan. That is between 2004 to 2004 it started, and we have around 16 batches of industrial automation students from all the branches of engineering. That's the real thing. So you had almost all the sessions covered in this 5 days workshop. It's too heavily loaded for the diploma students as well as the engineering students as such, for anybody for that matter. What is going to be very important is today's afternoon, I'll be presenting the advancements which is happening in the area of robotics. What could be the future of robotics? That's what I'll be talking about. So very, very nice. And let us get into this now. Okay, I'll go to the presentation. Let us have it very slowly. And some of the chats, you can always do it after I finish the video. I'll have a talk on that video, then start talking to you, okay, interacting with you. Let us have this now. So, Dhruv Kumar, are you there? Hello.
Yes, sir. Yes, sir. Yes, sir. I am here, sir. Here only, sir.
I'm just getting into this. Can I copy a file and then put it now only?
Yes, sir. You can open there only, sir. No problem.
There only. Okay, I'll do that.
No problem. You can open, sir. We are visible, sir.
Let us have it very freely, Dhruv Kumar.
Okay.
Any kind of technical snacks, you can make it out so that all the participants should enjoy my lecture. That is the kind of motive I had before starting this. Let us get into it. Yeah. So this is advances and future of robotics. I'll be getting into. Okay.
Okay, sir.
And on that day, I started some of the slides which I could not explain to you because of the paucity of the time. Let us say, see, before getting into this, let me tell you very clearly that the robotics as such, you have, all of you have know the definition, you know the working, construction, everything. You have everything here. But if I ask you very clearly, what is a robot? Can you tell me the precise definition of a robot? It's very difficult if you start thinking. I can give you one of the modern definition of robots, that a robot is a system. It is a system consisting of 3 subsystems. First one is the motion subsystem, which is a mechanical system, which has all the linkages, then movements, train, chains, everything, kinematics, everything associated with it. So that is motion subsystem is the first one, very basic skeleton of the robot. Then you have control subsystem, okay, and you have the recognition subsystem. The control subsystem and recognition subsystem go together. The control subsystem contains all the softwares embedded in a computer, or necessarily in a CPU, and it has total interaction or interface with all the sensors the robot has to have. So that is nothing but the recognition subsystem. So any system, if you say, it is going to contain these 3 subsystems, I am going to say that it is a robot. You can kindly recollect on that day that I went for, sorry, I should have gone for F5. Just a minute. I'll go to this F5. Let us see. See, all the definitions, they start telling you that robot is a reprogrammable, multifunctional manipulator designed to move material, parts, tools, specialized devices, so and so, through variable program motion. All these are okay, but they are all outdated definitions. This is according to International Robot Association of America. This kind of definition started coming and people were really in confusion until I can say up to 1980. These kind of things started happening. And even the robotics system did not develop so far. And the advent of artificial intelligence really gave an impetus for robotics field. And what happened is, artificial intelligence in robotics is always going to aim at developing machines that appear to exhibit human-like behavior, such as understanding a language, learning, reasoning, solving problems, scene analysis, etc. So unless you have artificial intelligence, this is going to be very, very difficult. The robots, like computers, also has generations of developments. The first generation robot was an open loop robot. I think I gave last time this system. Now here, if you see that, there should not be double-ended arrow, only single-ended arrow. That means only instructions from CPU will go to the operation unit of the robot. So if you make that, then it is going to be a simple open loop robotic structure. All the robots in the world, they require 3 things. One is information about a task has to be there. That means robot should know what kind of task it has to do. An energy source which has to drive the complete motion subsystem of the robot. Then inside the robot, you're going to see here, you can see here, there is a computer, there is an energy source, there is an articulated mechanical system, actuators, which are nothing but drives, transmission systems, everything will be there. So that you can see here in the operational unit. So then, depending on the task which is going to be given, depending on the interpretations the CPU is going to make, the instructions are going to go to the operational unit, and the robot end effector starts interacting with the workspace. Maybe end effector, or if it is a mobile robot, the robot starts moving. So this is what is precisely needed. So you're going to see a complete detailed architecture of the robot like this, which you can take it for granted that this is a robotic system. Okay? Anything, any device, machine, if you are going to, think about an NC machine, can you call it as a robot? Yes, in some sense it is a robot because it has all the three systems, but not fully as that of a robot. It doesn't have artificial intelligence, but you can put it. If you put all these three into a CNC machine, then CNC machine is going to act as a robot. That's what you are going to have. So there are so many things which started coming, and what I do is, in order to inspire you people, why I'm just getting into some of these video clips taken from the movie I, Robot, taken from a movie called as Bicentennial Man, some of these clips. See what happened when robotics started, it was a concept. See, actually, there was, after this World War I, that was somewhere in 1920, there was totally blooded slavery in the entire world. People wanted to use human beings as slaves, blooded slaves, to, fulfill their whims and fancies. And they were slavery. In order to avoid this, there was a scientific novel, fiction, came from a British writer, the Czechoslovakian writer, Karel Čapek, who wrote Rossum's Universal Robot, and there the word robota started coming. And because of that, I think you must have heard all these things. And afterwards, what happened to that story I told you on that first day? Let us see what could be the kind of, things which are going to see. After you see the clips, I'll stop it and then explain. Let us get into this. Now let me get into the first one. This is law 1. A robot may not injure a human being or go to this. This was done by Sir Asimov.
This is my dream.
You see this architect?
You're right, Detective. I cannot create a great work of art, place what robots need. Look, you can see them here.
This is a robo architect.
Deactivate.
Let him go.
It's not going to
He's a
hurt
robo
us.
soldier.
I gave you an order.
He's not listening. Yes, miss?
Now jump. No.
So here in this video clip, what did you see? You saw 3 rules for the robot. These rules came mainly because people, scientists, are afraid that the robots are going to malfunction if they are going to be implemented. And there was, first generation scientists earlier. One who was, father of old robotics, called as Joseph Engelberger. Then Unimation Company, Ford Motors Company, all these companies were involved. And there was one Sir Isaac Asimov who made his rule and told that there should be a prescribed rule for robots. Now that's what I was, trying to show from that iRobot movie, that one of the robot was a very useful architectural robot. It was, within seconds it used to give any kind of imaginative picture to the scientist and then discussing with him. And the next robot you saw was a soldier which started misbehaving and then, started fighting against the master. Then like that. Then there are movies like Bicentennial Man, where that girl is asking that robot. Actually, what happened is that robot is a humanoid robot. It was a human thing transformed into a robot. That kind of concepts were there. All flimsy concepts in robotics started coming. And because of that, things started. But I told you, the first generation robots are open loop robots. Second generation robots are the robots which are going to have artificial intelligence and recognition system there, sensors there. They are second generation, but artificial intelligence was not developed up to 1977. This happened. Then after computers, everything started, growing so much, and integration of technology. The third generation robot started. The third generation robot is nothing but the robots which are going to be self-learning type. This is what is required to the order of the day. Because if you are going to make robots, with all artificial intelligence, neural networks, and fuzzy logic systems embedded there, then the robots are going to be self-learning in the sense based on the experience it is going to gain by number of examples or tests. It makes a software on its own, and given any problem, it is going to tackle that. I also explained to you what is degrees of freedom in a robot and all those, and I told you a simple human hand, if you're going to see, it will have 16 degrees of freedom, and putting motors directly onto the hand is going to make the weight of the robot too heavy and uncontrollable. So the concept of indirect drive started, and lots of development started coming, and this presently we are in a world of robotics. I tell you, there is a booming, growth in the field of robotics. That's what I was telling you. I went into one graph which I specially designed. You are seeing this hallmark of all this development: 1920 Karel Kopak, 1956 NC machines, 1970 computers started coming, 1982 all digital signal processing, then ICs, then integrated ICs, all this large-scale integration, very large-scale integration, then digital processing. So all this started contributing to the growth of the robotics, and there is the ebb of activities, maximum development took place, and people started loving. But all of a sudden, there was a sudden slump only because of that problem of problem. Hello?
Sir Mohan,
Just for your information, our honorable H.U. Talwar has joined the session, sir.
Okay.
Yes, sir.
So,
Continue, sir.
What should I do now?
No, continue.
Continue. Just for your information.
I really invite Professor Talwar sir to this beautiful workshop, which is really extra work, energetic work from the Polytechnic. This is really 173 government polytechnics participating on the Atal scheme. Really, congratulations, Talwar ji. You are there as one of a pillar for encouraging all of you, all these people here. And
sir, we on behalf of Government Polytechnic Harpanalli extend a warm welcome to H.U. Talwar sir. Sir, the session will continue till 3:30. Then we'll start the validity session. Thank you for your time, sir.
Talwar sir is there, and who else is going to join?
Sir, he'll be there.
Okay.
Yeah.
So, Talwar sir is listening to seeing our videos?
Yes, sir.
Oh, thank you, sir. Talwar ji, welcome. So, I was talking about, growth of robotics, which is an index of any national progress, which I told you. And year 2000 problem really made the robotics growth slump. And all of a sudden, the growth started coming down. And there was a mismatch of technologies, artificial intelligence, expert systems, everything. And robots started even malfunctioning. The meaning of it is an industry. In the Japan, there was in 1986, 87, there was an article telling that robots stabbed the worker. That news started coming. So robots are going to misbehave, stab workers, everybody, and do cause injury to the human beings, and robots which were allowed to play with the kids, they started hitting the kids. So these are all, dangerous and hazardous. So in order to avoid this, those Asimov's rules started applying in the industries. They made a, complete embarkment, and they made rules that robots should not enter into that Lakshman Rekha inside, and they should not cause any havoc, and they should not be unnecessarily started without pre-knowledge. So all these things started. Then afterwards, 2005, 2002 to 5, the internet started, booming up, and all the people started using internet, and people had all the knowledge in the world in their computers, and it started helping the growth of robotics. And the present growth of the robotics is very, very going in an explosive way that you have seen. So I told you about the structures, everything which you have seen here. Now let me get into some of the robots I showed in my PPT earlier. These robots, the modern robots also, but I'll not get into that because today's time is very, very short. I'll get into very important videos which will tell you the story of robotics. How this integration of technologies can give you the design, modeling of robots, design, all these things easy. You can see in this video. Watch this. Dhruv Kumar. Hello, Dhruv Kumar.
Yes, sir. Yes, sir.
Are you seeing all this with clarity?
Yes, sir. Yes, sir. It's visible, sir. It's
Yeah,
visible.
I can give explanation, commentary also here.
Sir, actually,
It's not necessary. Okay. So you can see, if you have a CAD/CAM software, robotic systems, everything, all these things can be, drafted in 2D, and you can make a evolving 3D structure, and the entire simulation can be done on a worksheet. So this is the, importance of this kind of robot. And on that day, I was explaining you, if you start seeing the developments, real advancements in the robotics, I told you, the Mumbai Taj Attack, if you remember, it happened in, I think, 2007, if I'm all right. And it happened in Taj Hotel. The terrorists attacked, so many, residents of the hotel, killed them and everything. But if you happen to have these micro and nano robots that time, and if you happen to, make them completely sensor controlled through some software, and made these as insect robots, carrying each of them one drop of cyanide, then all these robots could have, entered through a UGD duct, or through the UGD pipeline, or through the AC ducts, and killed stinged all these terrorists within no time. So that kind of technology is already coming up. People are working on that, nano robotics and other things. And I showed you that I'll just go to some of the clips and then show you that the robots, shape and this thing may not be human being like. It can be a robot like this.
Vacuum cleaning robot. The latest in a line
So,
of robots
it's a
designed to
cylindrical
help you
robot.
maintain cleaner floors. Roomba cleans routinely so you don't have to. In your busy home, floors get dirty every day. Now with the push of a button, iRobot Roomba helps you stay ahead of the game and clean more frequently.
What it has inside that
Roomba's
is,
patented three-stage cleaning system features a powerful vacuum and two counter-rotating
see
brushes.
that inside.
Its revolutionary system reaches deep into your carpet to remove an amazing amount of
So this
dirt,
I showed.
dust,
I'm not going to,
and
show it again because it's going to be waste of time. Then I'll go to some of the robots which I did not show you. This is a robot which is very, very helpful in underground drainage cleaning. See, this is a robot developed by Pennsylvania State University, Louisiana State University students for about 20 years, and it's going to be commercial. It enters through the UGT ducts, and it is totally, leak-proof, and enters and goes through the pipes, cleans everything, comes out very, very cleanly. This is a micro robot. So this is what it does. Actually, you'll have to analyze for the components and everything. You can always look into that. I'll stop it here and go to the next slides. See, what I mean from all this is that the shape of the robot, earlier concept of being humanoid is not going to be there. But if you think about, the latest robot, another robot which was done by Louisiana State University and with whom I had a lot of interaction earlier was AgBot. It's an agricultural bot which you are seeing here. I'll show you. Here. I'll just quickly go through
the power of artificial
what it requires.
Energy
From the sun.
The power of artificial intelligence. Cutting-edge wireless communication. And advanced mechanical engineering combined together to create a marvelous entity called the AgBot.
This is the AgBot, which has come commercially and patented by Louisiana State University now, and it is available for $5,000 US fully. It was worked out by 20 batches of students. It has an online GPS system. It has all these, sowing, drilling equipments here, manuring, fertilization, everything that you can see. See inside.
Picture this. A healthy green lawn which is perfect.
What it is going to do is given here. I'll not, go through again because it's going to take a lot of time. I'll go to the functioning of that.
Sufficient for a medium-sized backyard.
I'll quickly run through because I showed it in the first lecture. See what all it contains. And it does fertilization, it does the sowing, seeding, everything. It cleans the
The
glass.
AgBot uses advanced GPS technology.
These are the things it does.
Unlike charging,
It avoids. It's a manual process.
the AgBot is equipped with sophisticated patented technology, which includes a seed hop for GPS.
So you can see.
First will be fertilized.
So many robots can be there cooperatively. So, and what is the beauty of this robot is that
It will guard
what
your
it is
house
going to
while you're
do
asleep.
in the night,
Now,
it will act as a
the
night
AgBot is
watchman.
equipped with a night vision pan and tilt camera. While guarding your house in the night, if anyone tries to break in, using its advanced image processing software, it will immediately set off a loud alarm and in the process, take a snapshot of the intruder.
So this is a beautiful product which came, and all of you can, start working on these kind of things because this workshop has given a really brainstorming, insight into the robotics. But I'll get into another beautiful video which tells what is the state of the art of the development in the robotics field. There's a robot called as Navo. It's one of the best, world's best robot, humanoid robot, which you can see here. See here. This is a Navo robot, next generation. It has all sensors, you know. It has artificial intelligence, expert system,
How
sensors.
are you today?
Hi, Liz.
It can speak any language.
Are you ready for some work this morning?
Sure.
See, everything is programmed here. And it has a tactile sensing, it has infrared rays, Ethernet connection. Whole body motion is totally coordinated motion. It has a beautiful eyesight. It recognizes objects. It holds.
Denise and my friend.
Come here.
It has adaptive walk. Pressure sensors will be there. Everything. It has one beautiful phenomenon which you are going to see. It's a
Try again.
there is going to be what is called as a fall manager. You can see. Now it's going to fall. Yeah, due to obstacle, it falls. Immediately fall manager is a software which has inertial sensor. It picks up on its own, gets up. This is one of a very, very hard task in robotics. This man took 50 years to have.
It doesn't hurt.
So I'll simply, run through, let us see. And the same type of robot is Honda's Asimo robot, which you are seeing here. Let me get into the, some of the beautiful aspects of this. Honda Asimo. Let us see what is going to happen. This is a robotic revolution. This can go along with the crowd, put his arms along fellow colleagues, walk into the crowd, give public speeches, anything. It plays football. You are going to watch. It is playing football with Obama, the American president also. It recognizes people. It has every details about this man now. And what for he has come and is taking into the corporate office. It avoids people, gives way to the people. See?
Asimo was created by Honda's research and development subsidiary. We were allowed to film their top secret robotics laboratory. Japan is a worldwide leader in the development of humanoid robots. Asimo is the country's crowning achievement. Engineers continue to make improvements. Osimo's most innovative feature is its advanced intelligence. The robot can think and act on its own without human intervention. That's made possible by sensors that replicate our 5 senses. Osimo's head contains 8 microphones. It uses them to listen and engage in conversation. 2 cameras work as eyes. They can detect humans and use stored data to identify them.
The facial recognition problem? I don't think so. Please cover your face.
Osimo's artificial intelligence analyzes a vast array of information. That's how it understands people's requests and takes appropriate actions. Osimo also has a sophisticated sense of touch. Its fingers can make subtle movements, like a person's. Sensors are embedded in the fingertips, too. They can gauge the hardness of an object, like human fingers do. Most robots use a fixed amount of strength to grab things.
I'm just, playing this in detail because you'll understand the complexity and the mathematics control involved here. Pouring of, liquid from a flask onto the cup is really difficult. See, all these things, I don't know. I'll say it's a very complicated robot which has beautiful AI and expert systems. Now, I'll just say, run through.
It can reach speeds of up to 9 kilometers an hour.
It walks 9 kilometers an hour. It runs.
For robots, walking is much easier than running. When running, both feet
Running is very difficult.
the ground. Balancing in midair is no easy task.
Because of the dynamics of the CG.
Maintaining posture while jumping or floating in the air was a major technological breakthrough.
These are all the advancements, I mean.
Its upper body slightly forward to maintain overall balance. It goes forward straight in the air.
Sensors in Osimo's waist measure the robot's angle. It leans slightly to compensate forward or back, side to side. That's how it stays perfectly balanced in the air. Osimo has been evolving ever since development began in 1986, much like a growing child.
Now this is Obama, who has been invited
Let me show you.
by the Honda company.
Here I go. I can see the top walk too. I can keep it right too.
Okay, come on, right here.
Here I go.
See the kick, it's so precise. Anyway, that is one of the robots. Then another one, drawing robot, I'll show you. Is a beautiful, simple, modular, and all the motors, they have a links themselves. And we have so many motors, Israeli robots, which have this kind of capability, which you are seeing here. What it does is it takes the complete picture, sees the man who is there for the portraiting and starts sketching. I'll show the developments, that's all. I'll quickly go through. See how it is going to sketch. That is the final thing, okay? Beautifully it does. And all this, you can make. There are, modular motors which can be joined like this, and they have the links. They start working, and you can program and have the control system like this. This is another robot which was done in Boston School of Dynamics, which has produced beautiful, wildcats robots, which you are seeing here. Highly dynamic and very fast moving, like cheetah, tigers. See the racing speed here, lot of things, and the stability it is going to maintain during running, and it's unimaginable. And the kind of inertial sensors, then gyroscopes, gyrometers they have, it recovers on its own and does any kind of, withhold any kinds of bounding, impacts, all these things you see. Beautiful. It turns, does everything. Anyway, I'll go to the same Boston Dynamics, number of things on different terrains. It's in the forest, it does, wood cutting and all these things, goes on in it. Now I'm going to show one of a robot, which is, I think you must have heard Sophia, the lady robot. This is called Actroid. An actor, working in the platform of Android. This is Actroid. This is the development stage of Actroid. Listen to his words. アンドロイドを組み合わせた言葉で、ロボットなんですけども、人間そっくりなパフォーマンスができるというロボットです。最初にですね、この若い女性のロボットを作ったのが、個々の男性のスタッフだけだったんですね。で、男性のスタッフが顔とか、先ほど言った目とか、髪型とかを全部決めて一回作ったんです。でところがですね、非常に出来上がったものは、まず個々の女性社員に大不評だったんですね。全然こんなの受け入れられない。When females designed it, nobody accepted. But when male employees started designing and did everything, everybody liked, both men and women. So that was the Actroid robot. A lot of things are happening, but I go later on because number of advancements in that. Sophia came and number of robots started coming. Then the world's biggest, highly successful astronautical robot has been the Mars Pathfinder. See, that's put on the Mars through a parachuting mechanism, and Mars Pathfinder is a 6-wheeled autonomous robot which you are seeing here. It is put on the Mars surface. It worked more than 30 years, highly successfully. And every day it walks It moves around 40 miles and gather the sample of the Earth or the Mars, send it to NASA, do chemical analysis there only if required, send it. It's one of a beautiful robot, which I think a couple of years back it stopped its functioning, which was launched in 1986. This is the robot. You must be, imagining what happened to our, lunar project, Chandrayaan-2. Till we have that Chandrayaan-2 robot intact, but recovery stage is on. Let me get into that is about the Mars Pathfinder. Then we'll go to the other robots. This is a complete view of that, how it is going to move, everything you are seeing here. Okay, this is the terrain movements. You have lots of things happening here. Okay. Anyway, so these are some of the advancements which you are seeing here. I just wanted to show you another robot, which is a cooperative robot. What it does is it does cooperative operations. Both the robots, they have a master-slave control strategy. They have hybrid control theory. They work on that. They coordinate in such a way that you are seeing a complicated sketch is really drawn on this object, which is held by this first robot. Very, very complex operation. Then you have some of the robots which does welding. Now here, this welding robot, what it is doing is, you must be seeing its cabling mechanism. So the simulation was done mainly to, make this cabling very optimized so that there won't be any interference. I'll go fast again because lots of things I have now to show you. There's going to be a revolution, which I can say, in robotics. We started coming in the year 2010 by means of quadcopters, hexacopters, and these devices. They are unmanned aerial vehicles, which you are seeing here. It's a beautiful TED talk which gives idea. Small robot.
Good morning. I'm here today to talk about autonomous flying beach balls. No, agile aerial robots like this one. I'd like to tell you a little bit about the challenges in building these and some of the terrific opportunities for applying this technology. So these robots are related to unmanned aerial vehicles. However, the vehicles you see here are big. They weigh thousands of pounds, are not by any means agile. They're not even autonomous. In fact, many of these vehicles are operated by flight crews that can include multiple pilots, operators of sensors, and mission coordinators. What we're interested in is developing robots like this, and here are two other pictures of robots that you can buy off the shelf. So these are helicopters with 4 rotors, and they're roughly a meter or so in scale and weigh several pounds. And so we retrofit these with sensors and processors, and these robots can fly indoors without GPS. The robot I'm holding in my hand is this one, and it's been created by 2 students, Alex and Daniel. So this weighs a little more than 1/10 of a pound. It consumes about 15 watts of power, and as you can see, it's about 8 inches in diameter. So let me give you just a very quick tutorial on how these robots work. It has 4 rotors. If you spin these rotors at the same speed, the robot hovers. If you increase the speed of each of these rotors, then the robot flies up, it accelerates up. Of course, if the robot were tilted, inclined to the horizontal, then it would accelerate in this direction. So to get it to tilt, there's one of two ways of doing it. So in this picture, you see that rotor 4 is spinning faster and rotor 2 is spinning slower. And when that happens, there's a moment that causes this robot to roll. And the other way around, if you increase the speed of rotor 3 and decrease the speed of rotor 1, then the robot pitches forward. And then finally, if you spin opposite pairs of rotors faster than the other pair, then the robot yaws about the vertical axis. So an onboard processor essentially looks at what motions need to be executed and combines these motions and figures out what commands to send to the motors 600 times a second. And that's basically how this thing operates. So one of the advantages of this design is when you scale things down, the robot naturally becomes agile. So here, R is the characteristic length of the robot. It's actually half the diameter. And there are lots of physical parameters that change as you reduce R. The one that's the most important.
See here, the radius of this quadcopter is very, very important. And there are factors you must have heard, velocity, acceleration, and differential of acceleration is jerk. Differential of jerk is going to be called as snap. All these controls are going to be done here in this beautiful thing. You can see.
Important is the inertia or the resistance to motion. So it turns out the inertia, which governs angular motion, scales as the fifth power of R. So the smaller you make R, the more dramatically the inertia reduces. So as a result, the angular acceleration, denoted by Greek letter alpha here, goes as 1 over R. It's inversely proportional to R. The smaller you make it, the more quickly you can turn. So this should be clear in these videos. On the bottom right, you see a robot performing a 360-degree flip in less than half a second. Multiple flips, a little more time. So here, the processors on board are getting feedback from accelerometers and gyros on board and calculating, like I said before, commands at 600 times a second to stabilize this robot. So on the left, you see Daniel throwing this robot up into the air, and it shows you how robust the control is. No matter how you throw it, the robot recovers and comes back to him. So why build robots like this? Well, robots like this have many applications. You can send them inside buildings like this as first responders.
Please see these applications. This is very, very important. These robots can do a lot of things. You must be knowing, the great scientist who recently died, a physicist, and he was using this. I'll tell his name later on. Just see.
Look for intruders, maybe look for biochemical leaks, gaseous leaks. You can also use them for applications like construction. So here are robots that are carrying beams, columns, and assembling cube-like structures. I'll tell you a little bit more about this. The robots can be used for transporting cargo. So one of the problems with these small robots is their payload carrying capacity. So you might want to have multiple robots carry payloads. This is a picture of a recent experiment we did, actually not so recent anymore, in Sendai, shortly after the earthquake. So robots like this could be sent into collapsed buildings to assess the damage after natural disasters, or sent into reactor buildings to map radiation levels. So one fundamental problem that the robots have to solve if they are to be autonomous is essentially figure out how to get from point A to point B. So this gets a little challenging because the dynamics of this robot are quite complicated. In fact, they live in a 12-dimensional space. So we use a little trick. We take this curved 12-dimensional space and transform it into a flat 4-dimensional space. And that 4-dimensional space consists of X, Y, Z, and then the yaw angle. And so what the robot does is it plans what we call a minimum snap trajectory. So to remind you of physics, you have position, to the smooth, and to control, and then exit. So the robot is obviously capable of second. It also tells the robot where these obstacles are. And the obstacles can be moving, and here you'll see Daniel throw this hoop into the air. Well, the robot is calculating the position of the hoop and trying to figure out how to best go through the hoop. So as an academic, we're always trained to be able to jump through hoops to raise funding for our labs, and we get our robot.
See this? it is, found out dynamically where is the hoop, and then it is passing through that in the central. A lot of things can be done here. We can make these robots enter buildings, then
So another thing the robot can do is it remembers pieces of trajectory and then does this pirouette.
There are a lot of things which I showed you. I'll go through very fast. This kind of coordinated motion is also possible here, which I'll show you with.
Again, if you have lots and lots of robots, it's impossible anonymity on the fly.
See here.
So again, these robots come really close together, as you can see in this figure 8 flight.
This is working on a principle called as swarm particle theory.
They come within inches of each other, and despite the aerodynamic interactions with these propeller blades, they're able to maintain stable flight.
And finally, in this, it was playing music. I'll show that. Coordinated motions. They especially made for this lecture,
for the very first
which
time.
I'm This is reconstruction of buildings.
So the robot then figures out what the features are, it builds the map, it figures out where it is with respect to the features, and then create a map, and then come back to education. Before I play this video, I want to tell you.
This is the music played by a group of robots. Every tone here was, performed by these robots only. They played. None of them is from the outside. Anyway, I think that's enough of it. Now, if you happen to watch these quadcopters, this is an amazing, innovation the humans have done presently, and these robots, they are really helpful. Even I had 2 batches of students work for flood relief operations for Coorg, then taking medical drugs and other things to the destinations, then flood relief operations, then identifying a particular unknown location, then finding out what could be the kind of topography, what is the kind of geography it has, and what inside architecture, everything can be traced out with this. My students had worked, and I'll tell you, the famous physicist who worked on black hole theory was none other than Stephen Hawking, who expired last year. You must be knowing. And this man, Stephen Hawking, was really, he was a completely crippled person because of multiple sclerosis disease. He was suffering from what is called as neuron motor disease, and due to which his entire brain was inactive. The entire body was inactive, brain was only working, and he was using quadcopter to, communicate with people, see people around, and do everything. That is one of a lively example one can use these robots. Now I'll get into a lot of things like this. Number of applications are there, and I have really beautiful coverage of all these things. Now we'll have to start worrying what could be the kind of future robotics which you're going to have. So before getting into the future robotics, I just want to come back and then say how this robot started. It started with what you call as Industry 4.0 onwards. What is Industry 4.0? Industry 4.0 is nothing but the complete digitalization, era of digitalization, where the IoT, Internet of Things will be there, sensory things will be there, and interaction of these things with Internet of Things and cloud computing is nothing but Industry 4.0. The Industry 4.0 actually started in 2010, and we are still not yet exhausted there, but Industry 5.0 also has started now. This is 2019 onwards. Roughly, you can have, Industry 4.0 totally around 70% achieved at 2018, and 2019 Industry 5.0 started, which is nothing but introduction of artificial intelligence and machine learning systems in any device, in any machines. You start putting up, and in particularly if it is going to be in robotics, it's going to have what is called as personalization. Personalization means everybody in the world now wants robots as non-blooded slaves, which can really give all sorts of comforts to the human beings and obey the instructions, whatever you are going to do, give them and start working on their own. So, and help the human being. Now, this is what I call as personalization, which I'm going to go through in detail. And before that, let us get into some of these slides, future robotics. Let us see what is happening. This YouTube is getting loaded up.
Well, 100 years ago. What could be waiting for us in another 50 years? We promise you won't have to wait long to find out.
My name is Kate,
And I'm Thomas,
and we're going to tell you about the future.
which starts today. Robots are taking our jobs. Somebody is waiting to leave us. What? No, answer the question. They do guided tours, deliver lectures, and report to you.
What is a robot's favorite kind of music? Heavy metal. Ha.
Robots have learned to feel. They even fill our bed now.
And I will always try to do everything you want me to do.
How will this technology change life in 50 years? Do you want to see it right now? Do you take Michael to be your husband? And do you, Michael, take Erica to be your wife? Yes, I do. You can now exchange the rings.
Don't marry him! We love each other. It doesn't matter that you're brand new and I am an old model. So you could run 300 miles per hour and I have a screen for a mouth. Or that I stammer when a cell phone starts ringing beside me. Our love is the only thing that really matters. I love you more than anyone else in this world does. Can I make you the happiest robot in the world? Or do you want to marry this boring brand new bride? Oh, you're breaking my tears.
Well, time does fly by, because 50 years ago, we used to think of robots like this. And then the designs changed until suddenly he came, the future governor of California.
In 1984, human-like robot was a pure fiction, but today it has become real. Some people would call him a madman and a naughty professor. Others think that he's creating the future. Japanese professor Hiroshi Ishiguro is one of the 20 most ingenious people of our time.
I have created the first Android. I got a question.
Hand and face molds help to and ask questions. He even tries to make jokes.
How do you stop a robot from destroying
relaxation? I don't know.
Don't. Ha! How about another one? What is a robot's favorite kind of music? Heavy metal. Ha!
Geminoid now successfully replaces the professor that works and gives lectures. Erica has already signed a contract with a Japanese TV company to work as a TV host. Haha. So the next
This is the world's most sophisticated and state-of-the-art robot called Gemini. That I'll tell you later.
question is from Eileen.
Wait a minute, are you telling me that a robot became a TV host?
Yeah, and what's wrong with that?
Our program has ended. I'm running out of power. Whoa.
Very funny. By the way, we're not the only ones who could lose their jobs.
Oh, come on. How many other jobs could robots possibly take over?
Believe me, doctors, engineers, technicians, even astronauts are all in danger. And in Britain, they even want to implement governmental robotization.
I wonder how that's going to work. Your request has been accepted. Your request has been denied. Good day.
Well, it might improve politics.
Actually, I know a robot who's made quite the career for himself. He started off selling flour firm who spread all over the world to practice. $30,000. Special characteristics: personal auto search, active gesticulation during your conversation, and facial recognition. So you're the first Russian tour guide robot. I want to ask you something. Do you have a salary for this? The question is not appropriate. Today, robots are made in clean shops at a real factory. Cleosha's prototype was built under extreme conditions in one of the programmer's garage.
У нас количество крышей бывало такие случаи, когда мы приходим с утра на работу, в гараж, а ночью шел дождь, а наш компьютер все в воде.
Now, Cleosha and his brothers each have 16 laser and ultrasound rangefinders, several cameras for loss intelligence is based in this unremarkable building. How are you today?
I'm in a good mood for a Tuesday.
Do you have any advice for me?
Perhaps I have advice for me, but I do have an ever-growing intelligence.
Harmony, the world's first sex bot. Country, USA. Height, 5'6". Cost, $10,000. Special characteristics: she is always ready and never has a headache. This is Harmony, one of the latest designs. Its creator, Matt McMullen, assures us that it can have real feelings and fall in love with its owner. Humanity has been fascinated with the idea of sex robots for hundreds of years. You know, this is not anything new. Harmony matches the standard image of beauty. She looks like a Barbie doll. She's got a thin waist and big breasts. The face comes off. The idea is that I will have availability of 10, 20 different faces. My name is Matt.
Nice to meet you, Matt.
So I'm going to put her face on so she doesn't look so strange. In the setting options, you may choose your perfect girlfriend's temperament. There are many options, including capricious, fierce, and modest. Harmony can even remember all your family members' names, your favorite color, book, and movie. Are you ready for your interview?
Just give me 5 minutes. Finishing my makeup.
Sounds just like me. Just 5 minutes. Okay. So let's skip. Работать со сварочным аппаратом, выполнять захват различных более габаритных грузов.
And he also knows how to do push-ups and even how to shoot using both hands. The secret of his sharpshooting lies in 15 range. You're the perfect man. I mean, robot.
Americans, they already going to be picking up the stakes and actually hitting the humans. This is a 2013 model. Clumsy Atlas could barely walk around lab then. In a year, he came outside and walked some distance on slippery snow. By the year 2017, he has learned the basics of parkour. Here's one more unique development from American engineers. A four-legged robot spot me, can serve beer, take out the garbage, walk upstairs, and open the door. The self-propelled four-legged platform has been developed for the U.S. Army. They're very scary, but they can also be turned into machines for war. So maybe decide now what are the rules before simply people develop it, and we find the dogs chasing us rather than being useful to us.
You want to destroy humans? Please say no.
Okay, I will destroy humans.
They are still not perfect, but it's just a matter of time. Military dogs may slip up. Even ultra-modern Atlas can't always keep his balance. Robobots are sometimes so overloaded with information that they just freeze. Without special controls, Japanese androids turn into ordinary silent dolls, and Geminoid is controlled with the help of a joystick.
I am Geminoid HI2.
The robot is really with a complicated intelligence. Then we have to take into account also interaction with.
Please see here that you must have watched a movie, Enthiram, by Rajnikant. See, what is the theme of that movie? You must be knowing. What do you mean by Enthiram? Enthiram means it is my prowess. That means the best human skills. That's going to be embedded into the robot there, and robot, becomes a real envy for the scientist himself who created it, its own creator, and it starts having, love, sex, and the physical emotions, the psychological, emotional feelings, which really makes the inventor of that robot envy, and finally it started loving the wife of the owner who created its own creator. That's what it was. It was a kind of tragedy which we saw there, and this is going to happen in the world also, that you are saying. Let me wind off this, then I'm going to get into Geminoid and all these later on. Let's get into.
Mohan sir, so dear all participants, actually sir, Mohan sir has left by mistake here. So they will come back again within a minute, short while. So wait for a minute. And meanwhile, Principal DRR Government Polytechnic Harapnalli, the Government Polytechnic Davangere, GB Sadanandappa sir has joined our meeting. So welcome to you, sir. Yes, sir. Yes, sir. Now you can answer. You can tell the final words.
Mr. Hello, am I audible now?
Yes, sir. Yes, sir. You are audible, sir.
Yeah. See, I'll just get into my slides immediately and then wind off within another 7 minutes. Is it okay?
Try to complete as early as possible, sir.
Okay.
Because all dignitaries are waiting here. All principals are joined. Some colleges, other colleges.
Okay. I'll go to my immediate slides. Okay.
Okay, sir. Thank you. So, dear all participants, GB Danchete sir, BVS Polytechnic principal has also joined our meeting. So, welcome to you, sir, from Government Polytechnic Harapalli.
Thank you, sir. Thank you.
Yeah. Welcome to the principal, sir. I am in the end of the session, and
Yes,
what my opinions are about future robotics advancements, I am just putting them in a concise form. Many unsolved problems in robotics and control have the potential for providing career challenges, scope, and opportunities in multiple fields of technology of the next generation. By 2050, robots will have human psyche, emotion, consciousness, artificial intelligence, personality, artificial personality, everything is going to come out. And that's going to be the cream of what you call as Industry 5.0. Then robots helping the mankind in agriculture, military, assisting needy ones, loving relationships, becoming ever-smiling partners is going to be Gemini robots, then Sophia, Actroid, all are the examples which I showed you. However, there exists a gulf of difference between creative imaginations and the actual state-of-the-art robotics. But all of you participants, please, if you develop interest in robotics, start thinking about these topics. These topics are number of things: assisting aged personalities, aging population, old people, nursing and child care, military, socially assistive, domestic, gaming, firefighting, underwater, exploration, smart robotics, swarm, which I showed you that quadcopters, which can be used for relief operations, which can be used for killing these terrorists in hidden places. Then biomimetic robots, which was developed mainly by Defense of American Research Project Agency, DARPA, and NASA, and agriculture robots, farming robots, then medical surgery, space, micro, nano, navigation, loving, caring, all these robots are going to be there. But what I can tell you is that in 2050, there might be an occasion where, you'll have the humans marrying the robots or making these robot spouses. They're going to be really going to be there. And there has been, a lot of things which is done by David Levy of one of a university there. And I'm coming to, how to improve our robots. There are plenty of questions which you can just see here. What jobs are going to be taken by robots and computers later in a short while? Advantages of robots, then insurance. These are all 13 professional things which will be taken over by robots within another 10 years. So this is insurance underwriting, warehouse and manufacturing jobs, customer service, research and data entry, production line, then local TV advertisement, pharmaceutical discovery, banking services, and outbound sales, fast food centers, long-haul trucking. Long-haul trucking is a very, very difficult task where, these truck drivers are going to be made robots, delivery services, and all the tasks that can be learned can be there. Now, there will be some of the ridiculous questions. Can robots cry? They definitely do not cry, bleed, or feel like human beings, but that all depends on what kind of artificial neural network and moderated neural networks that make the human brain simulated and machines work. These are the things. A lot of things are going to be there. There are a lot of advantages, disadvantages in robots, and why robots can never replace the human beings. That's only because of the human psyche and lack of emotional feelings in that. So that you're going to see. And the jobs, the robots cannot do it is perception, manipulation. Humans outspace robots when it comes to perception and motor skills, especially unstructured work environments, very, very difficult. Humans are good at it. So are robots a good idea? Yes. And if you're going to be asking me a question, what is the most realistic robot, which is a Geminoid, which I showed you, that lady after that Sophia, this was done by Professor Ishiguro, revealed a female android. He worked more than a decade, and that robot has become realistic now. Now, will robots take over the world? Definitely. There are going to be 20 million manufacturing jobs around the world by 2030. And economists claims every day, according to the study, that within next 11 years, around 14 million robots will be put to work in China alone. That you must have seen in Corona also. And what is happening is the robots, they are going to be really, really creative. And you can see here the technology in 2030 could be dominates the discussions, individuals, governments for good reason. Then STEM technology, they're going to be very, very strong environment, which everybody is going to be engaged. Driverless cars, and they will become, 50% of that. And I did not, expose another thing, deskless workers, the workers who are going to work anywhere, from anywhere, any kind of job with a handheld and computers. And in future, it is predicted that 50% of the deskless workers are going to be the robots in 2040. So this is going to be my end of the conclusion of the marathon. I can say it's nothing but the advancements and the future of the robotics field. So thank you one and all for your patient hearing, and welcome to the chief guest, DTE, and the principal, and all the Karnataka Polytechnic teachers who are there, the students especially throughout the country you're watching, and all the best for a new challenging career in robotics. Thank you.
Thank you, sir. Thank you, Mohan, sir, for your wonderful session and also valuable time spent with us. So yeah. I cordially thanks to you from on behalf of our institution, principal and staff, sir, and also on behalf of participants also, we thank you very much for your kind cooperation and your valuable knowledge sharing with us, sir. So thank you so much, sir. So we have, yes, thank you, sir. So we have principals of different colleges. So that first I will would like to invite GB Sadanandappa, sir, DR Government Polytechnic Principal, to give some some explanation or feedback about our program. So GB Sadanandappa, sir. Hello, Sadanandappa, sir, can you hear me? Okay, no problem. Our another respected principal, GB Dan Shetty, sir, is present here. They are principal from BVBS Bagalkot. So I request Dan Shetty, principal, sir, to give some inputs about the program, sir. Hello. Okay, no problem, sir. I think
you can call upon Rashikar Madpati, who is there.
No problem, sir.
Hello.
Hello, sir.
Yes, sir. Tell me, sir.
Yeah, sir. The session is good, sir. So the way of conducting and everything is very good, sir. And
yes,
then,
yes, sir. We have
first day itself, I am watching the program, sir. It is very excellent, sir. Mainly forward and inverse kinematics, and then the robotic and automation. The sessions are very good, sir. And then they are saying a lot of things, new advanced topic related to the sensor, how the industry is going to be automated in future. So everything is very fine, sir. Mainly the person from IITs are explaining the dynamics of equation and the kinematics of equation is very good, sir. And what I have to say, the question they have prepared for the dynamics of equation is also very good for that 20 question. So the program is very nice, sir. The way of you are conducting the time at the exact time, and you are not bothered about the participants. So it should be very good, sir. Thank you for your conducting this kind of wonderful workshop, sir. Thank you, sir.
Thank you, sir. Thank you so much, sir. So now we have Principal GB Dan Shetty, sir. Sir, please express your views on our STTP, sir, our FDP, sir. Dhansheti sir, can you hear me? Hello, Dhansheti sir.
Speaking. Hello, speaking.
Yes, sir. Yes, sir. Please, it is over to you, sir. You can.
Yes, sir. Can you hear me?
Yes, yes, sir. Yes, sir.
Yes. Sir, can you hear me?
Yes, sir. Yes, sir. We are hearing, sir. Yes, sir. We can hear you, sir.
Yes. Good evening to all, sir. Sir, it gives me a great pleasure, and it is my proud privilege to share some information regarding this workshop and the arrangement. So today's workshop or the training program regarding robotics is a very important and essential component of technology. And in future, already I have heard some information regarding previous resource person. By 2030, will be a driverless car. That is definitely no doubt at all. And regarding this training program under that Atal Academy. Atal Academy means AICT Training and Learning Academy. So this academy is doing a wonderful job in the training domain. So the training and learning is a part and parcel of our teachers. Teachers means each and everybody who is living on the earth, he should have a training and he should learn. So learning is a continuous process, and such type of training programs are always required for the faculty members because they want to update the subject knowledge and as well as pedagogy also. So for that purpose, this Atal Academy is doing a wonderful job from AICT. And I heard the Harapanadi Polytechnic, Government Polytechnic, this is the only one polytechnic right now which have received a permission or a grant or the authorization from Atal Workshop, Atal Academy. So on this behalf, I congratulate that principal and coordinator and all the faculty members. And one more thing, today you are all hearing about National Education Policy 2020, NEP 2020.